Hey guys, we are going to solve the 50 challenging problem box question 1 today, that is the sock drawer. So it says that let me check for once if my audio is accessible. Yes, it seems fine, thanks. Sorry for the inconvenience. Anyways, a drawer has red socks and black socks. When two socks are drawn at random, the probability that both are red is half. How small can the socks in the drawer be? Number of socks in the drawer be. Okay, so let's say that the number of red socks are this, number of black socks are b, r and b. So what is the total number of ways in which we can select two red socks, rc2, and what is the total number of ways in which we can select any two socks, r plus b c2, right? Because there are r plus b total socks, and they say that this probability is half. If we simplify this, we get r into r minus 1 by r plus b into r plus b minus 1 will be equal to half, right? So if that is the case, now we can do a brute force approach at this point to get the value of this, to get exactly how small can the number of socks in the drawer be, right? But I don't like, I'll ultimately do a hit and trial, basically hit and trial, but I don't want to do hit and trial at this point at this point, because it seems too much calculations as of now for this, and it will be too much of a brute force, and I want to do easier brute force than this. So I need some range, right? I cannot exactly get the value, I'm sure about that. So what I do is I r by r plus b is greater than r minus r plus b minus 1. If b is greater than 0, then this is always true. Why? Because there is a result which says x by y is greater than x minus 1 by y minus 1 if x is less than y. So r will be less than r plus b if b is greater than 0. So this condition, like for let's say 2 by 5 is greater than 1 by 4. Okay, 2 by 5 is greater than 1 by 4. Obviously this is 0.4 and this is 0.25, right? Similarly 2 by 3 is greater than 1 by 2, something like that. You can just prove it by multiplying this to cross multiplying, and you will easily understand why this is the case. So you will get r square by r plus b whole squared is greater than r into r minus 1 by, from this I am multiplying this both sides, r plus b minus 1 r plus b, which is half, obviously, which is given in the question, this equation. So r squared is greater than r square is greater than half this thing. So 2 is greater than r plus b by r whole squared, 1 by b by r, 1 plus b by r. So root 2 is greater than 1 plus b by r, right? And hence we can write root 2 minus 1 is greater than b by r. This, I guess you understand. Okay, now at this point we can do hit and trial. B equal to 1, r equal to 1. Is it going to work? Nope. B by r is 1. So 0.5, no, this value is 0.414 approximately, right? Because 0.2 is 1.414. So b equal to 1, r equal to 2, is it going to work? No, 0.5 is not less than this. B equal to 1 equal to 3 does work, and if you check out, this is the minimum number of socks at least which you can keep if b is greater than 0 and r is greater than 0. So yeah, so that is it. So this is the first part. And how small is the number of black socks is given. Again, you need to do some hit and trial for this also. I'll leave this part to you. Please solve this question please solve this part, and if you face any issues, I will surely help you up in the comment section below. I hope you like the video. We'll be covering this book, so let's see how far we can go. Okay, so yeah, that's all about it. Okay then, bye.